So the period of sine, the sine function, which this is 0, let's put pi there and 2 pi. So the period of just the sine function with no transformations will be 2 pi. The period is 2 pi. What's the domain of sine function? What do you guys think is the domain? All reals, because it will go forever to the left. So it keeps going in a wave to the left and forever to the right. So the domain will be all reals. So write down all reals. What's the range of this function? The domain is all the inputs, the range is the output. It goes from where to where on the outputs. This is theta, this is the output. What's the highest it goes? It's the unit circle. Didn't the unit circle, remember, what was it? The highest it goes 1. The lowest it goes is -1. So the range will be including -1 to including 1. -1 to 1. All right. So on the test on Friday, this right here will be the very important that you understand this to make it easier on you to get some of these problems. What is this? Is it even or odd? And I was supposed to do a lesson like on its own on even and odd functions. So, but I'm not, and I'm just gonna go over it right now, real quick. So what is an even and what's an odd function? Basically, let me go do something else. Let me show you. Okay, let's go over this. Go ahead and, I don't know, someone go ahead and write this down. You got X and you got Y, and you got this graph going like this. What's the equation of this line? It's going to be y equal to x. This is y equal to x. So this is just, if x is 1, y is 1, 1, 1, y equal to x. So this line is y equal to x. So y equal to x, the power of x is 1. So y equal to x, the power is 1. Okay? So now, if I do this transformation to it, okay, let's go y equals x. So I'm going to do, let's call it a function. F of x is equal to x. Same thing, y equal to x is f of x equal to x. If I do this transformation to it, if I replace the x with f of negative x, I'm going to get a new function. So if I do f of negative x, so for every x, I'm going to put in negative x. So that x becomes negative x, okay? And let's call it a new function. F of negative x equals negative x, and just call it g of, this thing becomes g of x. It's just call it some other g or whatever, it's negative x. So what does g of x equal negative x do? Well, isn't that just reflected about the x-axis? Every time, well, whenever there's a negative in front of x, it just reflects it about the x-axis. So g of x will be this function here. Let me go use the different color. So g of x will be reflected, it will be this. All right, so that's what I got so far by doing this. Well, actually, you know what? This is so crazy because it's also reflected about the y-axis. See, look. With this particular one, now, like, have a good imagination. Imagine that I fold with respect to the y-axis. So then this is going to be this, and this is going to be that. In reality, This one is by doing a negative x, is actually a reflection about the y-axis. But then let me do another thing here. What's going to happen if I do this? What if I multiply by a negative both sides? What's going to happen to here? Let me see. Multiply by a negative 1. Multiply by a negative 1. So I'm going to get negative g of x. Negative g of x is equal to negative times the negative of positive x. And then I'm going to divide by a negative. Okay, I'm going in circles here. In reality, you know what it is? This is doing too much. All right? What I'm going to do is, how many transformations do I have to do to get back what I have? Let me go back and redo this again. All right, look. So, what I'm saying is this, look. How many transformations do I have to do to get back to this? So, if I do one transformation, maybe visually would be better. If I reflected about the x-axis, this is x. If I reflected about the x-axis, I'm going to get this graph like this. Okay? Because you're reflecting it, no? Yes, yes. And if I reflect it again, so the first one about the x-axis. And now if I reflect it with respect to the y-axis, what's going to happen? If I reflect this yellow line with respect to the y-axis, what's going to happen? It's going to go back, yes or no? Do you say how many reflections I'm doing? I'm doing, look, if I reflect it about the x-axis, it's going to become this yellow. And after I do that reflection, and I reflect it about the y-axis, it's giving me back this red line. So it requires two reflections. Okay, let me now explain how this one's going to work. That it is an odd function. This is going to be an odd function. Why? Because if I do this, and I got this sideways s, I go like this. Okay, so that's the sideways s. Let me do the reflection about the x-axis. If I do a reflection about the x-axis, I'm going to get this. It's going to go like this. Yes or no? Yes? If I just flip it, no? But, okay, so now, you know that this sideways s is going forever here also, no? It's going like this. Okay, so it's going over here. So I want to get another, I want to land on the actual sideways s. So if I flip it over with respect to the y-axis, and isn't this red one going to land on top of this one here? Yes. So if I only do one reflection, I'm not landing on the blue, on the side, on the blue curve. So it will need two reflections no matter what, as opposed to this one, where this one is. Which one is this one? Which function is that one? The cosine function. So if I only do one reflection of it, watch, if I go like this, if I do only one reflection, and that reflection is with respect to the y-axis, isn't this going to land on top of this? Yes or no? So look, for even, not just remember, for even, you need only one reflection. Whereas for odd, you will need two transformations. Now, this is the formula you will need. Now here we go. This is it. See, it would have been better if I had done a whole lesson on this to really, but this is all you really need. What you really only need is that we're going to say that for cosine, f of x, I guess, we can just go x instead of theta. F of x is going to equal to negative f of x. F of x is equal to negative f of x. Nope. Is that true? Is this true? Is it true? Hold on. Hey, somebody over there, can you stop? You're messing me up here. Would this be true? See, we need to really analyze this. What input is this one right here, everybody? What's the input right there? Let's go with theta then instead of x. Let's go with theta. What input is this? Pi over 2, thank you. Isn't this pi by 2? Isn't this pi isn't 3 pi by 2? Isn't this 2 pi? Isn't the, yes or no? So f of pi by 2 is equal to, what if we go here, this will be what? Negative pi by 2, yes or no? F of pi by 2 is equal to f of negative pi by 2. So my statement was not correct. This is a correct statement. Because f of pi by 2, what's the output of pi by 2? The output of pi by 2 is what? Just say 0. And the output of negative pi by 2 is what? Also 0. Yes? So f of negative pi by 2 is equal to f pi by 2. So for even, this is the correct thing to test. It's called f of, you want to do theta or instead of x, is equal to f of negative x. F of negative theta, not x. Whereas in this one function, we need two transformations. So we need to do this. And we said that the graph was let me do this color. All right, let me test, what is this again? Okay, what is this? For sideways S, what is this? Pi by 2? Somebody said pi by 2 because it's pi, no? This is pi by 2. So now let's go. And then here's the other one. I could have just looked at this one. All right, let's go. Okay, so here pi by 2, what is this? Negative pi by 2. Okay. We want them to be the same. But because pi by 2 is positive 1 here, negative pi by 2 is this negative. So what are we going to say? We're going to say that, is this true then? Let's see. F of theta is equal to negative f of negative theta. Let me see if this is true. Now, I'm analyzing this. I'm not memorizing. So let's go. F of theta, where theta is pi by 2. Let's say is f of pi by 2. Is that equal to negative f of negative pi by 2? Is this true? Let's see if this is true. What is f of pi by 2? F of pi by 2 is the y value. What is it? 1. Room 208. Yes. Okay. Adam, your mom's here. Look, do you guys really understand what inputs and outputs are? F of pi by 2 is what? 1. F of pi by 2 is 1. Yes or no? What is f of, let me do this and do this. What is f of negative pi by 2? What's the input, what's the output of negative pi by 2? It's negative 1, and then I have a negative in front of it that makes it a what? Positive 1, yes or no? So, this is true. This is true. F of theta is equal to negative f of theta. But the way the book has it, the way the book has it is this way. They like to keep, let's see, they like to keep a negative on the other side. Let's see. So if I divide this by negative 1, then that gets rid of this. So f of negative theta is equal to negative f of theta. So either one works. Okay, so for odd, we can remember this. Look, here we go like this. These statements are true. Let me erase everything. Okay, so for odd, For odd, you need two transformations. Flip it over and flip it over, which would be that. So this is an odd function, and we're going to say that f of, let's go with negative theta, or let's go with f of theta. Let's go with the first one, either this one. F of theta equals negative f of negative theta, or we can just also say that negative f of theta is equal to, because I'm divided by then f of divided by negative, f of negative theta, f of negative theta. Okay, both statements are true. F of theta for odd. F of theta equals negative f of negative theta, and f of theta equals, or negative f of theta equals f of negative theta. And this is going to help you when we go back to the unit circle and try to get these sines and cosines of it. Is it continuous? This is getting into calculus, and this is just a very general way of defining what continuous means. Continuous means that I can draw this blue curve or wave forever. Now it's red. And never lift my pencil. It will forever and never lift my pencil. Never lift my pencil. As opposed to this other function, maybe, as an example. Let me see how good you remember things. That was so long ago. What's this function? Impress me, one person. So the name of this function is y equals 1 over x. So this function y equals 1 over x, it is not continuous. It is not continuous because I can draw this curve forever like this, but it's never going to ever meet that one. And they're like separating forever and ever and ever because there's an asymptote in between. Okay? In any case, continuous, when you say continuous, is that without lifting your pencil, you can just forever draw this curve. So it is continuous. All right. So what function is that one right there? It's a bird, but in math it's called a cosine function. And now if I can just stamp it and stamp it and stamp it, think about it like that, then that is the period of it is also what? What's the period of this function? What's the period of cosine? What would it change? The period is still going to be what? 0 what? Pi, that's pi and 2 pi? It's 2 pi? So the period of cosine is 2 pi. What's the domain? All real numbers? What's the range? What's the range? Can somebody just like guess, I guess? What's the range? The range that you see it is greater than, where do you see in terms of y? You see it, the lowest it goes negative 1 to 1, negative 1 to positive 1, negative 1 to 1, including negative 1 to 1. Is it even or odd? It's even. Even. Is it continuous? Yes, it is. It's forever going as a curve. Forever, you're not lifting your pencil. Yes. All right, so these are not the other trig graphs. These are the ones we've been doing for like the last 2 weeks. Okay, so let's go to the other trig functions. Okay, so if you don't catch everything, you're gonna have to go to the website and get it. But we gotta move on because it's a long lesson. Here we go. All right, so we're gonna graph cosecant theta. What does the function cosecant theta look like on a graph? Okay, 0 pi by 2 pi 3 pi by 2 2 pi it's negative 1 to 1. Cosecant is the reciprocal function. What's the reciprocal function? Look. You guys do remember again? I had done this where I said cosine theta. The reciprocal function of cosine theta is what? You don't have to be writing this. What was the reciprocal function of cosine theta? Do you guys we're going too fast? We're going too fast? Do you guys ever go back and look at your notes and really learn this stuff? What was the reciprocal function of cosine theta? What's the reciprocal function of cosine theta? Cosine theta is not equal to SEC theta. That's why I call it reciprocal. Cosine theta is the reciprocal function of cosine theta would be the reciprocal function of what before. So that's not it. That's not it. What's the reciprocal function of sine theta? That one is going to be 1 over cosecant theta. So basically what we could say that sine theta is equal to 1 over cosecant theta. Okay, so sine theta equals 1 over cosecant theta, which I can again flip this and say that what? 1 over sine theta is equal to cosecant theta. Okay? So cosecant theta is 1 over sine theta. Which, why am I doing this? Because again, it's easier to do things with things you're more familiar with, no? So cosecant theta is equal to 1 over sine theta. And now we're going to do a table of values by figuring out these values, which are the values for this too. And on the unit circle, what did I say? On the unit circle, what is sine of theta? On the unit circle, x is what? I just kept saying x is cosine, y is sine. So we're going to do 1 over y. Yeah, on the unit circle. Yes, yes, all right. So let me put those numbers. Yes, let's do that. Let's do that. Why did I erase it? That was a really nice circle. Let me do another. Let me see. All right. So for this situation, for trying to graph this, I'm only looking at the y value. I'm looking at the y values only. But let's get all these points. Let's just, and then I'll erase them. Just. All right. Yeah, let me change it up for you. Mayra, coordinates. 0, -1. Yes. And if people are over there going like this in their notebook, I'm already seeing that you're not. It's not good. No. Becky, right here, coordinates. -1, 0. Okay, so maybe I think everybody got it. 0, 1, 0, 1, and 1, 0, 1, 0. Okay, all right. So we're only concerned with the y for what we're trying to do here. We're trying to graph the cosecant, which is 1 over sine. So we're concerned with this y value here, y value here, y value here. And hopefully with these 4 points, maybe we can kind of trace what's going on here on the graph. So let's do a table of values here. Okay. What's cosecant of 0? What's cosecant 0? All right, hold on. Who am I going to ask here? Cosecant 0. Cosecant 0. Over there. Where you at? Oh, you're not even on this. What happened to you? Giovanni, what's cosecant 0? Cosecant of 0. Anybody in this class, what's cosecant 0 without me teaching? You're like, why do you just ask us and not teach us? Because I'm not going to try to think. Well, you need to be thinking. What is cosecant 0? Like, what's cosecant 0? Nobody? All right, I'll do it then. Cosecant 0. Input for theta 0. Cosecant 0, cosecant of 0. Well, I don't know what that is. Why don't I put it here? That's the reason why I did this. So it's going to be 1 over sine 0, because it's equal to this. 1 over sine of 0. What is sine of 0? What is sine of 0? Why did I even draw this then? Sine of 0. Sine of 0 is 0? Huh? Yes or no? Sine of 0, so I go back over here and I say 1 over, what was sine of 0 that I just said? 0? And what's 1 over 0? 0? Get a calculator. What? I'm done. My teacher teaches, I don't know, hopefully a calculator can help me. What's 1 over 0? What's 1 divided by 0? It says divide error. It says the answer is, it's undefined. The answer is undefined. So so this should be the answer to this would have been, and that would have been like I would have been having a better day if you, Giovanni, you would have just said, hey, you came to the rescue, and you would have said, it's undefined. Like you're a refined person, like too easy. What's cosecant of pi by 2? Cosecant pi by 2, go. Put it, do it, and put it on your paper. What is cosecant pi by 2? Yeah, Aiden, what is it? Yeah, no clue. He's like, no, I'm not even trying. No. What's cosecant pi by 2, anybody? Say it. Why is this hard? What the heck is it? Cosecant is 1 over sine. Put it in sine. So you're going to look sine of pi by 2. What is sine of pi by 2? Sine of pi by 2 is 1. And what is 1 divided by 1? Pi. Cosecant of pi, cosecant pi. Can we speed it up a little bit? What is it? Is it negative 1? I'm trying to mess with you. It is undefined. Three power 2. That one is going to be negative 1. Yes? So what's this one going to be? Undefined? Okay, so how do we graph undefined? You're like, that's why I'm here. That's why you're teaching. How do you graph undefined? It's okay to just guess. What? It's a dotted line up and down. That's what we had in when I say, do you know y equals 1 over x? And because, some people are like, wow, why? Because if you plug in x is 0, 1 over 0. If x is 0, it's going to be undefined. And undefined look like this. And then that's why the graph looks like that. So, oh no! What did I do? What happened to that thing? What? Where did it go? Where did that? Oh! What's somebody trying to tell me it's right here? Look. Oh, it looks like a dotted line up and down, undefined, dotted line. Pi by 2, what was it? Quickly, pi by 2. Now, can you picture that in your head now? But it's a y value. What's the y value? What? It's 1. It's 1. So at pi by 2 is 1. And so at pi by 2, where's pi by 2 at? Yes or no? The y value is what? So I should put a what? Dot right there? Yes or no? At pi is what? Undefined? At 3 pi by 2 is what? And at 2 pi is what? Undefined? So now you're over here saying, what are you gonna do? Do we go like this, like connect them? Yes or no? Like, yeah, connect them. That'll be the graph. What did I say about this thing here? That thing is like, you will never ever meet, like ever. So everything in between is stuck in. So now, how do we graph this? What does the sine function look like? What does the sine function look like, anybody? What does the sine function look like? Hold on. You might not agree with me that it looks like a sideways dash, because you're going to say, well, it looks kind of like this. Well, a sine function looks like this. And what I'm going to do is I'm going to cheat. Unless you really want me to do some, we could do some more work. But I could tell you what it's going to look like. What it's going to look like, it's going to look like this. The graph is going to look like this. They will go the other way. So if this is curved down like this, the sine way, then this thing is going to go the other way and try to meet and try to get this becomes an on-ramp and trying to get close and close and close to this thing and get closer and closer to this thing. If you want to just get this done quickly. And so on here, it's again going to turn around and flip the other way. And try to get close to here, and as close to here like this. And then it's just going to continue on going like this. Like this, from left and right, it's going to go. I can't do it, but it's going to keep going like this. So over here is going to be what? Over here, here you're going to have and then it's going to go like that. Okay, it's going to go like this. The graph of it. At this point, it's going to go like this. And then another here. And then at this point, it's going to turn around like this. And so I'm just using this. I'm telling you, this is not really part of it. That's the graph right there. Is it continuous? Is it continuous? Absolutely not. It's continuous on its domain, but it's on the reals, it's not. What's the period of this function? What's the period of the function? Look. We already had what? This is 0, and it's going, 0 is going to, this is 0. This is what? Pi. That's 2 pi. If I get this stamp, say I get this stamp, only this stamp, and I try to stamp it everywhere here, am I going to get what I'm supposed to get? Yes or no? Anybody paying? If I just get this, say, and I try to stamp it here like this, am I going to get what I'm supposed to get? No. I need what? I need the whole thing all the way here, yes? Now if I get this stamp and I grab this, would I be get another one that's the same? So the period is going to go from 0 to 2 pi. The domain is, let me talk about domain. The domain is going to be all reals, x or theta, whatever you want to call it, x or theta, the input, cannot equal to what? Cannot equal to what? 0 plus any what? What is this? Is that pi? Any n pi. Where you can put 1 pi, 2 pi, 3 pi, 4 pi, or negative, where n is any integer. All right. So that's why x cannot equal to 0 radians or whatever plus n pi. What's the range? What's the range? What's the range? Where do you see the graph? Where do you see this blue parabola looking thing? Where do you not see it? Where do you not see it? It's not going to be in between here, yes or no? It's going to be everywhere else, no? So the range is that x, no, not x, but what? What is that? Not the input, but the output. Y is what? Just let's go, y is greater than or equal to, isn't it equal to what? If you want to, greater or equal to what? 1. And then also, I don't know, this is just so it makes, y is what? Less than or equal to what? -1. What's the best way to write this down? Well, you could just say, you can say that, switch it. Y is what? Greater. Y is greater than or equal to -1. Less than or equal to no. Y is pointing towards it. It's kind of, no, this is it. This is don't worry too much about this. We'll talk about this later. This is set notation about it. It's going to negative infinity all the way to -1, and from 1 to infinity. Maybe I should. Maybe we should. All right. Let me talk about this. The graph will go to negative infinity. That's why we say infinity is open. Negative infinity, comma, all the way to this point, which is -1. I'm not gonna do union. I'm gonna just do comma, and including, undo, because it's including this 1, including 1 to infinity, and infinity is open. Why not? Let's do it like this. All right, let me see how much you've learned today. Is this even or odd? Very easy, very easy. This is how I would do it. I would test for even first, because even is so easy. If I flip it over, is it landing on another one? If I flip it over, is it or is it not? No, it's not. So this one is gonna be, but if I flip it another time, look, one flip with respect, let me flip it with respect to the y, there. And if I flip it with respect to the x, am I getting it now? Yes or no? So it requires 2 flips for it to jump and land on itself, I guess. So it requires 2 flips odd. Is it continuous? And we already said it's a no. Let me, because I'm going to stop recording this thing. So let me go to how does it tie to Fridays before we do analyze secant and cotangents or whatever. Okay, you don't have to copy this down, but let me remind you on the unit circle that you should already know how it goes. That's in degrees, and then we got these in radians. You got pi, 2 pi, you got pi by 6, pi by 4, pi by 3, pi by 2, on and on and on and on, and how to get those. And then we got that is x1 0, 0 1, -1 0, 0 -1, and then everything over 2, start from the top. So it's going to be 1 root 2 root 3, 1 root 2 root 3. X's will be negative, because this is negative. So all the x's will be negative there and positive on the y's. Both the x and the y are negative. And then the x is positive, y is negative. All right, here it is. If you want to do well on the test on Friday, there will be some problem going like this. What is sine of negative pi by? No, let me make it a little harder. No, let me make it a little. Maybe I think it's harder. 7 pi by 6. Go. Why don't we already do a problem from the test on Friday? What's the answer to that without a calculator? Because I'm not going to let you use calculators. Figure it out. What is 7 sine of negative 7 pi by 6? Figure it out. No calculators. Go ahead and work it out. Oh, some of you guys are just already figuring it out, huh? Hey, if you figure something out on your own, that's what like teachers or whatever they go like. You know how to think on your own. My teacher teach me. Anybody got the answer already? You already got it? What? Huh? 1/2. 1/2? Okay. I mean, you might not even need this. Okay, so where's 7 pi by 6? 7 pi is right here. 7 pi by 6 is right here, no? The positive 7 pi by 6 is here. But we don't want this one. We want the negative one. How do we do it? Because we're supposed to, okay. What is 7 pi by 6 in degrees? That's the reason why I did this. Okay, it's 210, no? So 7 pi by 6 is 210. So really what you need to do is do sine of what? Negative 210 if you really want to do it this way. What's sine of negative 210? Well, negative 210, where's negative 210? Well, if I go back, I understand this better than, I go negative 180. How much more do I have to go? So it should be this one right here. And that's going to be sine, that's going to be 1/2. What did you say over there?
Well, 1/2.
You did say 1/2?
Yeah.
Can you explain to me how you got it? How do you think about it?
So I counted how much degrees it was, and then
So you did do degrees?
Yeah, I did it the other way. Like negative.
Okay. Look, I'm going to tell you this. That you could do it this way. Pay attention. Put on your thinking cap. What did I say? Sine of theta is equal to what? What was the whole thing I was talking about at the beginning? It's an odd function. If it's an odd function, okay, I had said something like negative sine theta is equal to what? I told you to write it down. Was this true? Sine of negative theta? Is this true now, everybody? Is this true? Sine of negative theta, and let's do it an example. Let me put in something for theta. Is this true? Negative sine of pi by 6. Let's go with this. Where theta is pi by 6. Theta is pi by 6. So negative sine of theta is equal to sine of, well, negative pi by 6. All right. Is this true? All right. Let's see if this is true. What is sine of pi by 6? Look at the graph. What's sine of pi by 6? That's not even that hard. So what is it, everybody? Yes or no? And we got a negative in front of it. Yes or no? So it's negative 1/2. Yes or no? So now, sine of negative pi by 6 is that, what is it telling you to do? To go down pi by 6, no? Go down 30? So what is the answer to negative 30? Because this is negative 30, no? That's easy to say. What's sine of negative 1/2? Oh my God. So you're like, I don't get it. What's the point? The point is, what's the point? That sine of negative theta is equal to what? Negative sine theta. So whenever you get something like sine of negative 7 pi by 6, that is equal to negative sine 7 pi by 6. You know what I did? Because this is equal to that is equal to that, and then that is equal to that. Then I can just go and do sine 7 pi by 6. What is sine 7 pi by 6? Sine of 7 pi by 6 is this, but with the negative, it makes it positive 1/2. Yes? So, but you have to really understand this relationship. When it's odd, sine of negative theta is equal to negative sine theta. Oh, you can just do it the long way, or you could do it like Giovanni's doing it, no? Let's do another one and see how we're doing with this. Cosine, give me something that's negative. Cosine what? Negative what? Okay, you don't want to give me. I'm just gonna, let me see. Go. What's the answer to this? Go. Figure it out. Figure it out. What would that be? This is even easier. This is like stupid. I'm sorry, Lord, excuse my language. What did I say? What did I say about cosine theta? This is cosine theta is equal to what? Cosine of what? Cosine negative theta is cosine theta. So, cosine negative 5 pi by 3 will equal to what? Cosine of what? 5 pi by 3. So just go to 5 pi by 3. Where is 5 pi by 3? Cosine? 1/2. Yes, you got it? Is that easy? Cosine is super easy. The other one, the sine is the one. All right, one last one before I stop and we continue on with the lesson. Sine negative 4 pi by 3. All right, let's go. Let's go. Do that one. Sine. All right, I got it. What is Evelyn? What you got? I think so. No, everybody? Yes. Why again? Because odd. That's an odd function. Then you're gonna say sine negative 4 by 3, 4 pi by 3 is gonna equal to negative sine 4 pi by 3. So just go to sine 4 pi by 3. Go to sine 4 pi by 3. Here, sine is the y is positive. Change the sign of it. Yes. Let me stop the lesson.